The periodic table is filled with radioactive elements, which are elements that are unstable and therefore decay. These radioactive elements may emit subatomic particles during their decay, which changes their atomic and mass numbers. Many radioactive decay chains cycle through many different elements. But what if I told you that most radioactive decay chains all end in the same place, with one particular element? So what is this element? Well, most radioactive decay chains end with lead, which has 82 protons. Lead is the element with the highest atomic number that has stable isotopes. That is, lead has forms that do not decay into smaller components. For example, a uranium-238 nucleus decay chain begins with the emission of 2 protons and 2 neutrons, leaving a thorium-234 nucleus. This process is called alpha decay, since an alpha particle, which is a helium-4 nucleus, is emitted. Then, an electron and an antineutrino are emitted from the nucleus to change one neutron into one proton, leaving a protactinium-234 nucleus. This process is called beta-minus decay, since a beta particle, in this case an electron, is emitted. The atom continues to undergo alpha decay and beta-minus decay, emitting protons and neutrons and also converting neutrons to protons by emitting electrons and antineutrinos, all the way to thulium-206. Finally, thulium-206 undergoes beta-minus decay one last time, leaving a stable lead-206 atom. This isn't the only decay chain that ends with lead. Here are just a few examples of radioactive elements whose final decay product is an isotope of lead, via the following chains. But what is so special about lead that is consistently found at the end of decay chains? Well, firstly, lead has a property that is known as magic, meaning that lead has a magic atomic number. But what are magic numbers? Well, a magic number is a number of either protons or neutrons that makes an atom particularly stable. Lead's 82 protons make its atomic number magic, and one of lead's isotopes, lead-208, has a magic number of neutrons, making it doubly magic. But what makes these radioactive elements decay in the first place? Well, their decay is the result of too much energy contained in the nucleus. Quantum calculations have found that nuclei with more than 137 protons cannot be bound. That leaves one magic number between 82 and 137, 126. If elements exist above oganesson, which is number 118, then 126 is likely one of them, and may be irregularly stable in comparison to neighboring elements. However, it is incredibly unlikely that number 126 is completely stable, since alpha and beta decay will likely occur because of the theoretical element's massive amounts of energy. Overall, it is quite interesting that most radioactive decay chains converge, and the reasoning behind it is understandable. Perhaps one day there will be a new set of decay chains which converge to 126, but for now, lead seems to be the rock of stability for the heavy end of the periodic table. Big shout out to my new channel members, Freesk and RealTHF. Thank you so much for your support. Thanks for watching, like and subscribe.